14D, number 3. A box contains 4 tickets. One of them is marked with a star and the other 3 are blank. 2 draws are made at random with replacement from the box. What is the chance of getting a blank on the first draw? 25%, 1 in 4. What is the chance of getting a blank ticket on the second draw? Whoa! Oh, a blank ticket, sorry. Sorry, blank tickets, 3 out of 4. Thank you. Okay. What is the chance of getting a blank ticket on the second draw? Still 3 out of 4. Why? We have replacement. We put it back in, which means the draws are independent. Okay, the first draw does not affect the second draw. What is the chance of getting a blank ticket on the first draw and a blank ticket on the second draw? Would be 3 out of 4 times 3 out of 4. So it's going to be 9/16. D, what is the chance of not getting the star in the 2 draws? It's going to be exactly the same as the last one, right? Not getting a star is the same as drawing a blank, so it'd be 9 out of 16. What is the chance of getting the star at least once in the 2 draws? So at least once is hard to do. So instead, so let me show you why it's hard to do. So we have a star ticket, and then I'm going to say blank 1, blank 2, and blank 3. Okay, so what could happen? Well, we could get star and B1, or star and B2, and then we have to go through and write them all out and count them, and it's a huge mess. So instead, we calculate the chance that it doesn't happen. What's the chance of not drawing a star on the first draw? 3/4. Right? On my first draw, I have a 3 out of 4 chance of not getting the star. Okay? Now what about on the second draw? I also have 3/4, which is 9/16. So this is the probability of drawing no stars. Okay? So what's the probability of drawing at least 1 star? 7 out of 16. And the problem you get here, even if we count all these up, we have to make sure that we don't count star star twice. Right? If we set up the lattice 4 by 4, then well, maybe I'll do it. So, because this is, so star 1, 2, 3, that's a star. 3, 4, and then star 1, 2, 3, 4. So I have stars here, and then star star 1, 2, 3, 4, and then I have stars here 1, 2, 3, 4. So are they mutually exclusive? No. There are 5 ways to do that, and there are 5 ways to do that, so you would think 5 plus 5 is 10 out of 16. But this got counted twice, so we need to subtract 1, and we get 9 out of 16. And that's not hard to do when you only have 4 tickets in the box, but when you have more than that, it gets kind of complicated. So instead of doing this, we simply count all of these and then subtract it from 16. So how many are going to be here? Well, that's 4 by 4, or wait a minute, did I do that wrong? Anyway, so there's no 4. That's the problem. There we go. That's better. So this is 3 by 3. There are 9 ways to not get a star, which means there are 7 ways of getting at least 1 star. Okay, number 4. A die is rolled 3 times. What's the chance of getting at least 1 ace? Well, if we want to do at least 1, then we calculate the chance of it not happening and we multiply it together. So what's the chance of not getting an ace on the first roll? 5 out of 6 times 5 out of 6 times 5 out of 6, which is 125 over 216. And then we find the opposite of that, which is 40%, 42%. Okay? And the same with 6 rolls. So it's actually really easy to calculate. All you have to do is 1 minus 5/6 to the 6th. And there's supposed to be a subtraction in there. 66%, 66.5. And the same for 12 rolls. We just change this to a 12. Okay, so the more times you roll, the more likely you are to get an ace. Will that ever be 100%? No. But eventually it will be so close that we're not going to be afraid to bet on it, right? Eventually we're going to be so close to 100% that it's pretty much a guarantee. Okay? And that's like the inverse lottery, right? So if you roll 1,000,000 times, what's the chance of getting at least one ace? It's almost 100%. It's true. So the lottery is the reverse of that. The lottery is like rolling dice 500 times and not getting any aces. Yeah, don't play the lottery. It's a bad idea. There have been